Hello, sixth graders, and welcome to 7.2, where we'll be talking about how to solve equations using addition or subtraction. Let's get into it right away and start with our key idea. For our key idea today, it says equations may be true for some values and false for others. A solution of an equation is a value that makes the equation true. All right, so for example, we start with our equation is x plus 3 equals 7. So something plus 3 equals 7. And it asks us, are both sides equal when the value of x is 3? Okay, so they took 3 and they said that's going to be our value of x. Okay, you can see they substituted it here. 3 plus 3 is 6. Does 6 equal 7? No, it doesn't. So that would not be a solution. How about 4? 4 plus 3, 7 equals 7. Yes, it is. 5, no, because 5 plus 3 would be 8. Okay, so the value x equals 4 is a solution of this equation. Basically, it's an answer that makes that equation true. We can compare an equation to a scale. If you've ever seen those old scales where it's got the base here, and then it's got a couple arms coming off, and it's a balancing scale, right? And then right here would be the equal sign if they're the same height and they're balanced. Well, in this equation here, if we had 4 plus 3 on this side and we had 7 on this side, well, your equation would be balanced just like a scale would. So a lot of times you'll hear me referencing equations are like scales, and whatever's on the left needs to equal what's on the right. Okay, so let's see an example of what that might look like here. All right, it says, tell whether the given value is a solution of the equation. All right, it says p plus 10 equals 38. And we're going to test when p is equal to 18, does that make our equation true? All right, we'll take what we know p is. It says p is equal to 18, so we will substitute in 18 for p. 18 plus 10, does that equal 38? Well, 18 plus 10 would give me 28, and 28 does not equal 38. So p equals 18 is not a solution to the equation p plus 10 equals 38. Let's try it for letter B as well. It says 4 times y, remember when they're just next to each other like that, that implies multiplication, equals 56. And we want to test this for when y is equal to 14. Right? 4 times y, and I know y is 14, does that equal 56? Okay. Well, 4 times, let's write it out here just so we can see. 16, carry my 1. 4 times 1 is 4, plus 1 is 5. So I get 56, does equal 56. So y equals 14 is a solution. So yeah, that does work, right? Key here is just being able to substitute in your different values of your variable into your equation and testing to see if that that solution works. Okay, so here I got a equals 9. 9 plus 6, does that give you 17? No, that gives you 15. Okay. Number 2, 9 minus g. Well, g is equal to 3, so 9 minus 3 will give you 6, not 5. So no. 7 times n, and that's when n equals 5. 7 times 5 is 35. 35 equals 35, yes. And lastly, q divided by 2 equals 28, and we're using 14 this time. So 14 divided by 2 would give you 7. Does 7 equal 28? No, it does not. All right. Hopefully you're catching on to substituting in a given value to the equation. Now here's a little bit more on how to solve these equations rather than just sticking in a different value to check the solution. It says you can use inverse operations to solve equations. The word inverse is kind of a synonym would be opposite. So you can use opposite operations to undo each other. Addition and subtraction are one example of inverse operations. They're opposite. If I add 3 to something and then I subtract 3 to something, those are opposites. You'd get back to that original. So for our key idea here, it says, when you add the same number to each side of an equation, the two sides remain equal. So if you had a statement, or remember like before when we said when we have scales, and you said 8 is equal to 8. That's true. Those scales will be balanced. If you added 5 to each side, well, those would still be equal because now you'd have 13 on the left and you'd have 13 on the right. If you were to do that with algebra, that remains the same. So we have x minus 4 equals 5. You can see here what they did is they did the inverse operation. So instead of subtracting 4, they undo that operation by adding 4. And if you add 4 to the left-hand side of your scale, notice they added 4 to the right-hand side of the scale as well. So 5 plus 4 gives you 9. So there's your answer. We'll do a bunch of these problems, so don't be too worried if you didn't quite catch on there. Same statement here. If you subtract the same thing from each side of an equation, your equation remains true. And lo and behold, it's the same for algebra. Okay, so let's try a few of these, and let me break a few of them down a little bit more for you to see if they make some sense. All right, it says solve x minus 2 equals 6. So when I'm looking at this problem, I'm thinking to myself, what number, when I subtract 2, do I get 6? And some of you might be able to do some mental math here and be like, oh, that's 8. If I take 8 and subtract 2, I would get 6. So that's good. But let me give you this little tidbit here is this type of algebra is pretty basic, and you can do some mental math. But it's going to get a lot more complicated next year, the following year, and even in high school. So what I want to teach you is the process of how to kind of break these down step by step, because like I said, they'll get harder. So little hint, I like to break my equation at the equal sign. Now I've got a left-hand side of my scale and a right-hand side of my scale. And it's now I'm thinking about how I can balance it. Okay. So what I do first is I ask myself, what is being done to my variable and how do I undo it? Okay. I'm gonna write that down, and I'd encourage you to do so as well. What is being done to my variable? And remember, that would be your letter, whatever it might be. And how do I undo it? Remember, that's what we just talked about up here is using the inverse operations. You can use inverse operations to solve equations or undo things, just like I said here. So in this case, for letter A, I have x minus 2 equals 6. What is being done to my variable? Well, x is my variable, and I see it's being subtracted by 2. So how would I undo subtracting by 2? Well, the opposite of subtracting by 2 is adding 2. And whatever I do to this left-hand side, I need to do to the other side to balance my equation or balance my scale. All right? Now let's look and see what we've got. I have subtracting 2 and adding 2. Those are opposites and they will cancel out. And notice now I'm just left with my x on the left-hand side, which is exactly what I want. I want to isolate my variable so that I can figure out what its value is. On the right-hand side, 6 plus 2 gives me 8. And there I'm solved for my variable. I've solved that equation. If I were to check that, again, I would take 8 and stick it into my equation here, substitute it, and check and see. Does 8 minus 2 give me 6? And yes it does. So I know I'm correct. All right, letter B looks different because your variable is now on the right-hand side. So we have 18 equals x minus 7. And it doesn't matter that it's on the right-hand side. That's fine. Nothing changes. I still have a left-hand side of my scale and a right-hand side of my scale. And I still ask myself the question, what is being done to my variable? Here's my variable, x. And how do I undo it? How do I undo subtracting 7? Well, the opposite of that would be to add 7. And if I do it to the right-hand side of my scale, I need to do it to the left. Negative 7 plus 7 cancels out. Those are opposites, subtracting 7 and adding 7. And I'm left with x on the right-hand side equals 18 plus 7 would give me 25. And you might say, does it matter that my 25 comes first or my x comes first? No, that makes no difference. You could write it as x equals 25. And that's the same thing as 25 equals x. But the order of those does not matter. Okay, why don't you pause here to try 5, 6, and 7 here on your own. And please, please, please get in the practice of showing your work. Right, for number 5, k is being subtracted by 3, so I'll add 3 to both sides. I'll come up with k equals 4. Number 6, n is being subtracted by 10, so I'd add 10 to both sides. And I'd come up with n equals 14. And lastly, r is being subtracted by 6, so I'd add 6 to each side. And I get 21 equals r, or remember, it's okay if I say r equals 21. Those are the same thing. Let me know if you have questions on those. For example 3, it'll be, now we're going to be using subtraction to solve instead. So let's go back to black here. I have x plus 2 equals 9. X is being added by 2. So to undo that, I would subtract by 2 on both sides of my equation, both sides of the equal sign. Adding 2 and subtracting 2 are opposites. They cancel out. X equals 9 minus 2 would give me 7. I can double check that by substituting 7 back into the original equation. 7 plus 2 gives me 9, and 9 equals 9. Likewise for letter B, again, now my variable's on the right-hand side. So 11 is being added to x, so to undo that, I would subtract 11 on both sides. Undo opposite operations. Adding 11 and subtracting 11 are opposites, so I'd be left with 15. X is equal to 15. And again, double check it. 11 plus x, 11 plus 15, does that give you 26? Yes, in fact, it does. All right, one more example, and then a few oils, and then we'll be done for the day. It says your parents give you $20 to help buy the new pair of shoes shown. So after you buy the shoes, you have $5.50 left. Write and solve an equation to find how much money you had before your parents gave you $20. So couple different things here that we need to do. Let's break this down a little bit. I'm thinking about how much I had. It wants us to find out how much money you had before your parents gave you $20. So the starting amount plus the amount your parents gave you minus how much they cost will give you the amount left. Starting amount of the shoes plus the money, or the start amount of what you had plus the money your parents gave you, and you subtract how much the shoes cost, that should give you the amount of money you have left. Let's substitute into this equation what we know. Do we know how much money we had to start? No, let's call that S for starting money. Plus the money your parents gave you, we know that's 20. Minus the cost of the shoes. Well, the cost of the shoes, you can kind of see here, it's a little bit maybe tricky to see, but it was $59.95. Add in a few labels here. Should equal how much money we have left, and we had $5.50 left, is what it tells me. All right, so now you'll see in this problem that we actually have two things that are being done to S. Right? I need to ask myself that question, what's being done to my variable and how do I undo it? Well, if I look on my left-hand side, it's being added by 20 and it's being subtracted by $59.95. So we need to undo both of these to get S all alone. Right? To undo subtracting $59.95, I would add that to both sides. That would cancel. And I'd be left with S plus 20 on the left-hand side still equals, okay, $59.95 plus $5.50 would give me a total of $65.45. And I still have to undo this adding 20 by subtracting 20 from both sides. That would undo, and now I'd be left with $65.45 minus 20, and that would give me $45.45. So you had $45.45 before your parents gave you the $20. You then took this that you started with, added the $20, bought the shoes for this price, and you had $5.50 left. All right, go ahead and pause the video now to do 8, 9, 10, 11 on your own, and we'll see how you do. All righty, for number 8, what number plus 8 would give you 17? So, or if you subtracted from 8 by both sides, you should come up with S equals 9. For number 9, what number plus 6 would give you 9? That would be 3. Subtract 6 on both sides, in other words. That's how you'd come up with it. And 13 plus what number gives you 20 for number 10? That would be 7. Subtracting 13 from both sides to get that answer. And lastly, number 11, it says you eat 11 blueberries and your friend eats 11 blueberries from a package. There are 23 blueberries left. Write and solve an equation to find the number of blueberries in a full package. It's kind of similar to this one. So we're trying to find how many blueberries are in a full package. You ate 8 of them, so that would be subtracting 8 from the total. And your friend ate 11, so that would be subtracting 11. And that should equal how many blueberries are left, which is 23. So solving that, you need to add 11 and add 8 to both sides. That would cancel this. And 23 plus 11 plus 8 would give you a total of 42 blueberries. Okay? To start in a full package. All right, that does it for 7.2. Let me know if you have more questions. This is the very basics of solving equations and how you go about doing it. I will see you next time.